of yesterday in terms of applying our understanding of the discriminant. In this question, it wants us to show that the roots of the equation are real for all real values of p. Okay, so what is our endpoint? What is it that we want to find? What do you think this question is asking? Okay, so Jovan says b squared minus 4ac is not less than or equals to 0. How do you get that? It's not less than 0. Okay. Why do you say that? Okay, wait. Not less than 0. What inequality sign are you expecting it to be? Not less than 0. What inequality sign are you talking about? That one, what's the word for it? It's a word, yeah. Smaller than. So discriminant, smaller than 0. But you say not less than that.
Less than.
So you don't want the not word. See? See, when you cannot even verbalize or you have hard time trying to write it out the words.
So b squared minus 4ac is more than or equal to 0.
More than or equals to 0. Okay. Which means that your discriminant, you expect it to be more than or equals to 0, like that lah. Alright? Okay, so that's why I find it very strange that Jovan was saying not less than 0. I don't really like the word not lah, because you have to think in the other sense, okay, the opposite one, so it can be a bit challenging sometimes. Alright, so why is it more than or equals to 0? How do we get this idea? Because the question says that the roots are real. Okay, so this is our endpoint, this is what we want to find. Okay, so we want to find this one. Right, so how are we going to do that? Okay, we have the quadratic equation, right? Okay, so we will arrange it into the typical standard quadratic form by placing everything onto the left. Okay, so we can see very clearly what is the coefficient of x squared, coefficient of x, as well as the constant term, whereby a is 1, b is p plus 1, c is negative 5 plus 2p. Okay? Okay, so we find the discriminant. That will be p plus 1 squared minus 4, 1. C is negative 5 plus 2p. Okay? So our end goal is to show that this is more than equals to 0. We cannot claim that it is more than equals to 0 now. So from this step, what is the next step that you intuitively do? Open the brackets. Okay, so let's try that. P squared plus 2p plus 1. Then minus and minus is positive 20 minus will be 18. Okay, and then we arrive at p squared. 2p minus 8p is negative 6p plus 21. How are we going to justify that this is going to be more than or equals to 0? Yes, Alex. Complete the square. Will anybody in this class also have the same idea? To do completing the square? Or does anyone else have a different idea? Okay, my question here is, with this step, how are we going to justify that this is more than 0, more than or equals to 0?
After you use completing the square, bracket the square bracket, right? Okay, so that is the thing. I think that's what Alex is trying
Peter is trying to say is that when we do completing the square, we will get a certain form. Okay, remember? We will get something squared and then plus a constant. Okay, and this is very helpful because we keep all the variables, all the unknowns inside the square. Okay, and we know that whenever we square something, it will always be more than or equals to 0. Always positive, otherwise 0. Okay, so if this number is going to be positive, having a positive number plus a positive number, do you agree that it will still remain positive? Yes, right? Okay, positive number plus positive will surely be positive. So that is the way that we could use to justify. Okay, so let's do that. So I'll continue up here. P squared minus 6p plus 6 over 2 squared minus 6 over 2 squared plus 21. P minus away 3 squared minus 9 plus 21. That is going to be 12. Okay, so we get this. And then here's our expectation. Okay, where we wanted the square and then a positive number. Okay, so we can explain that since p minus 3 squared, okay, more than or equals to 0 for all real values of p. Okay, because question says for all real values of p, right? Okay, then p minus 3 squared plus 12 is more than or equals to 12, which is positive. Okay. Right. So while this one is not more than or equals to 0, okay, question is just simply saying that it must be real. Okay. So actually we can very clearly see that it will surely have 2 real roots. Okay. It is not possible to have 1 real root. Okay. So it still satisfies the fact that we wanted more than or equals to 0. Being able to show that it's more than 0 still satisfies this one. Okay, it still satisfies the condition that we want to show that it is going to be real. Okay, so we conclude, therefore, the roots of the equation are real. Right, so we show it to be. Questions? Okay, we move on. It asks, are there values of k such that the curve, which we have provided with the equation here, lies completely above y equals to x plus k, and we want to justify your answer. Okay, so how do we interpret this main question over here? Okay, where we want the curve to lie completely above. Okay, so if you say b squared minus 4ac is smaller than 0, why? Okay, so in case you haven't caught it yet, when we say that lies completely above a line, how does that actually look like? We're looking at the curve entirely above the line. So that means there's no intersection, and having no intersection will mean that your discriminant is less than 0. Okay, so what this question wants us to find is whether, okay, is it possible, right, for any specific value of k. Okay, so we can make that claim and see what happens when discriminant is less than 0 itself. Okay, or are there values of k such that we will not use this claim, we will try to see what comes out of the discriminant first. Okay, so given the curve equation and the line equation, we equate both of them since they are both equals to y. And we re-express it into our typical standard quadratic form so that we can recognize our a, b's and c. So the a is k plus 3, b is equals to, what is b? Actually I'm not simplified, right? Negative 4, huh? And k is negative k. So finding our discriminant, a is k plus 3. Then we will get 16 plus 4k squared plus 12. Yes. Do we simplify this? What do you mean by simplify? Huh? What do you think? Vicky says that can we divide all by 4? And then like that. We cannot do that, okay? Because this is not an equation, it's an expression. So this and this, they are not equal. Because you divide by 4, where does it go? Okay, so we cannot do that. Right? So you can, however, factorize out the 4 if you want to. But I'm not sure how is that meaningful. Let me just rearrange this first. Okay, you can factorize out the 4 to express it like that. So every statement is still equal. Okay. But then what does the question want us to do? Okay, we want to determine whether there are any values of k such that this can happen. Okay, so if we can complete the square over here, right, and see that it is going to be more than 0 or more than equals to 0, okay, then we can simply say that there are no values that can allow this to happen. Right? So if I want to complete the square, that means that we need to factorize on the 4, then we will plus 3 over 2 square minus 3 over 2 square plus 4. Plus 1.5 minus 3, 7, okay, plus 7. Quadratic, right? Any quadratic expression can complete the square one. Okay? Right, so once we do that, completing the square part, we see that the perfect square portion will surely be more than or equals to 0. Okay, for all values of k, because down here is k. Then we say that 4 times of it will still be more than or equals to 0 plus 7 okay, will allow the entire expression, the entire discriminant to become more than 0. So since the discriminant is more than 0, okay, your curve does not lie completely above y equals to x plus a. There are no values above the line. Okay. I can sense that your brains have not yet warmed up, but I hope that it's absorbing something. Yeah, prefer maths lesson to the first period or the last period actually. Later on. But I love first period lessons.
What is second period?
Huh?
Second period is the best.
After recess is better. Oh, okay. Interesting perspective.
No lesson is best.
Huh? No lesson better. You know that's impossible, right? Yes, sorry, generally.
Why is it then it's k plus 1.5 where is bigger than or equal?
Why is this greater or equal to 0? We did this a lot of times already. Because whenever you square a number, confirm positive what?
Oh yeah.
Ah,
Okay, yeah.
okay, so maybe you want to remind yourself about that. Okay. Okay, then we finish our part 2. Explain the relationship between the curve and the line. So when they ask for the relationship, they are actually asking for how do the curve and the line interact. Meaning to say how many intersection points are there. So what do you think? Based on what we have already done, what can we say about the number of intersection points? There will be 2 because discriminant more than 0. Okay, so I'll just add it over here, maybe. Okay, B. The curve and the line have 2 intersection points. Because the question asks to explain, so we need to say why. Because discriminant is more than 0. Okay. Alright. Let's take a look at try 7. Okay, last 2 questions for this topic. Okay, we look at the problem sum now. Okay, we must understand the question first. So it says that Jerry sells tires. Okay, I kind of truncated the question a little bit. Okay, so the revenue $R from selling X number of tires is given by this. Okay, so this is an important equation. Main question asks, okay, can Jerry's business generate a revenue of $20,000 in July? Okay, so we want to see if this is possible. Okay, so in order to generate a revenue of $20,000, that means that this expression over here, okay, will have to be what? Equals to 20,000? Is that the only possibility? Oh, it can also be more than 20,000, right? Because if you are able to generate something more than this, it also means you are able to generate. Right? Okay, so we are looking at whether your R, okay, is more than or equals to $20,000 or not. Okay, so that is what we're trying to see. Right? Wait on. So we want to check whether this is possible or not. Which means that, okay, if we have a quadratic curve over here, because this is a quadratic expression, okay, we want to see whether this minimum, okay, if it is not going to be of this shape actually. It is this shape. Sorry, let me backtrack a little bit. I shall remove this side. So I'm just trying to think how do I continue from here based on what I wanted. We concluded that the revenue is going to be more than or equal to $20,000. We want to do this. Okay, sorry. Because I think we kind of get slightly away from what I initially planned. Okay, so we were trying to actually check whether this revenue is going to be more than or equal to $20,000 or not, right? Okay, which means that I can also say our expression here, x times 200 minus 0.4x, is it going to be more than or equal to this? Okay, so in other words, okay, I'm trying to check whether this is true or not, right? Okay, so we can look for the discriminant for this expression over here. Okay, we're essentially actually looking at the curve and the line here. Okay, so what we can do as our usual method was to equate them first, so that we can find the discriminant. Okay, even if you don't equate, right? We can still find the discriminant now. Okay, yeah. Sorry, it's a square. Okay, then we can identify our A, B, and C. Then find our discriminant, which is going to be a number. And it comes out to be 8,000. Yes. Okay, so discriminant comes out to be 8,000, which is actually more than 0. Okay, so that means that our curve and the line, so this quadratic curve and this line, okay, based on how the discriminant comes out to be, okay, it means that there is actually 2 real roots. Okay, so there's an intersection, which means that okay, it is possible to generate a revenue of $20,000 if you like. I can that this one equals to 20,000 also? Huh? Is it? Is that the question?
You need to find like the minimum or like what's like minimum generate like 20,000. So that's why you do.
Okay, maybe the other perspective I wanted us to get, right, okay, was that this is a curve, right? Okay, this is an equation for a curve. It is quadratic when I expand it. Okay, it expands out such that my coefficient of x squared is going to be negative 0.4. So it's going to be of this shape. Okay, so if I want to draw this graph, how it will look like? It will look maybe something like that. I don't know. Okay, about the x-intercept. It might look something like that. Maybe actually, it will look like that. Okay, it will be a N shape, right? So the question is asking whether your revenue versus x over here, R is for revenue and x is for number of tires. Okay, will the revenue actually eventually meet the line $20,000? Okay, $20,000 is a certain value, right? So what the question is asking is whether this curve will it look like that? Okay, such that this will mean that it doesn't meet, or okay, if it meets, okay, it will either look like this, touching at one point where $20,000 is, or it could look like that, whereby there is a certain number of tires where you sell, okay, and then it will meet $20,000. Okay, so these are possible cases, right? So when we equate them, okay, and try to look out the discriminant, we are actually going to investigate which of these possibilities can arise. And we see that our discriminant is more than 0, which leads us to conclude that this is the case we say, okay, and hence it is possible to generate a revenue of $30,000. Get it? Yes, Karen. Cannot get it. Find maximum point, the maximum value of R, and then check whether is it more than or less than 20,000. Okay. I think that Gareth has a nice idea, alternative solution. Okay, so let me write that down. Okay, so what Gareth was saying is that can we look for the maximum value of R? Okay, what is the maximum point? And how do we do that? We can do our search for the turning point. Okay, there are many ways to do the search for turning point in this case. Either you do a completing square to look for the turning point, or based on this, actually this is a factorized form. I don't know whether you can see it or not, but R equals to x times 200 minus 0.4x is as good as saying x minus 0 times 200 minus 0.4x. Okay, so your roots are equals to 0, otherwise this one, okay, you solve it and you find the corresponding value of x. Okay, so depending on how you want to find your turning point, what is your preference? Or Gareth, do you have a preference of finding a turning point? No? Okay, so if you want to use this, so this is a quick revision for E-maths, okay? So if we use the roots here, x-intercept, that will mean x equals to 0, or 200 minus 0.4x equals to 0. Okay, 200 divided by 0.4, what is it? 500. Okay, so x coordinate of turning point, okay, we will get our 0 plus 500 divided by 2 equals to 250. So y coordinate of turning point will then be, when x is equals to 150, okay, is going to be $25,000. Right, so therefore that is more than $20,000. Hence, we can say that okay, it is possible to generate a revenue of $20,000. So we explain by saying since the maximum value of R equals to $25,000, which is more than $20,000. Okay, so Jerry's business can generate that revenue. Okay, so that's the alternative lah. But you find that this step might actually be longer than what we were doing.
I don't understand why when discriminant is like more than 0, then it means the 20,000 mark.
Because more than 0, when discriminant is more than 0, it means two intersection points, right? So between what and what is the curve, what is the line? The curve is actually this thing here, and the line you're referring to is a 20,000. So once it is more than 0, what does the curve look like? And with the line, it will look like that because two intersection points are there. Okay, so W is $20,000. This curve represents your revenue. So there is situation whereby you sell a certain number of tires that will generate for you a revenue that's greater than $20,000. Okay? Yes. Now,
Why don't you just say that x 200 minus 8.4x is like
why
bigger than or equal to?
I couldn't catch your question. Why the first step? Why is it equal to 20,000? Okay. So Vincent asked, why is it that we don't write this? Okay. The reason why I didn't write that was because, right, it is a statement that we're trying to verify. Yeah, it's a statement we're trying to verify that whether is that true or not. So I'm not sure yet, okay, whether your revenue would it be more than equals to 20,000. It could lead to this case whereby your revenue is actually less than 20,000. So we are not sure about this statement. Okay, so we're trying to investigate it. That's why we let it be equals to 20,000 and see what is the discriminant going on. Yeah. So after we found the discriminant, then of course I can be certain now. Okay, but right at the start of reading the question, I'm not certain about that. That's why I reverted into the equal sign rather than use the more than equal sign. Yes, Alex.
Other methods, could we use it or?
I also cannot hear you. I think I'm running there. Yes. For the other method, whether we can use it for finance. Is that a question? And if we use that method, will you be penalized? Or is that what you're asking? Okay. So Alex is asking, okay, for this method over here, will you be penalized if you use this in AMAS? Answer is no. Okay, this is a definitely acceptable method in terms of solving the question. So either you present this or present this. Okay, but is it necessary to go through these steps after we have learned discriminant? Not quite necessary. Okay, likewise in your EMAS itself, if you want to talk about discriminant, okay, nothing quite wrong with it, but usually it wouldn't require you to do so lah. Okay, yeah, that's why discriminant topics, okay, is mainly in your AMAS only. Okay, we don't quite use it in EMAS itself. Yes. In E and AR. AMAS, they ask for maximum value. Maximum value, you can do this second method, but this second method is one of the ways to find. Yeah, by using x-intercept, or you can do completing the square. That's the other alternative. Okay. It depends on what you are given, and then you seek for the most efficient method. Yes.
Can we also make it that like the graph is shape, then the 20,000 is equal?
Cannot, but because this graph itself, we have confirmed that it is this shape. Because when you expand, okay, your coefficient of x squared, okay, x times x will be negative 0.4. So confirm it's this shape. Okay. In fact, if it's this shape, okay, there isn't much to talk about. It seems like it's either above the line or else meeting the line. Yeah. Okay. And also a bit strange okay, for revenue to be this manner. Okay, any other questions? Right, I think the questions that you have asked are definitely meaningful. Okay, so I hope that those that did not ask questions, you have caught what your friends were asking. Right, let's look at another question. Okay. Sorry, give me a minute. Let me just contact. Okay, let's read question 10. baseball moves after it has been hit. Okay, so y represents the height above the ground and x seconds represents the time after it has been hit. We want to use the discriminant, so in this question it is very specific, saying that we want to use only the discriminant, so no way for us to explain via this method over here. Okay, to find the range of values of C if the baseball did not reach a height of 50 meters. Okay, so how do we interpret this question? Okay, you can try to understand how does this curve look like first. So based on the coefficient of x squared, which is negative, we know that the motion of the baseball would look something like that. Okay, maybe if you want a complete shape, something like that. Okay, so we want to check or determine the range of values of C when we face the situation that it did not reach a height of 50 meters. That means that your highest point over here is below your 50 meters. Okay? In other words, are there any intersections between the curve and the line? No, right? So no intersection means discriminant less than 0. Okay, so we can use the fact that discriminant less than 0 in order to determine the range of values of C, because that is what we want to find. So our goal is to find the range of values of C. So we are looking at the curve here interacting with the line, which is y equals to 50 meters. That's why we equate the two equations and determine the discriminant of this. Okay, so the C is C minus 50. Right? So this If there are roots, that means that there is an intersection. If there are no roots, okay, based on the discriminant, right, that means that there's no intersection. Yeah, because I'm trying to merge these two things together to form a new equation. Remember yesterday I said that between a curve and a line, okay, whether there's any intersections or not, okay, it is as good as drawing a new curve and see how many intersections with the x-axis is going to be like. Yeah, so that's why we equate to determine the discriminant, okay, to check whether there are any intersections or not. You know what I'm trying to say? Okay, so because the question says that it did not reach a height of 50 meters, that means that your discriminant will be less than 0. Sorry, my brain not breathing. Negative 600 plus 20c. 600 divided by 20, that is 30. Okay, so C less than 30. Yes.
Everything. Take it as 20x.
For the B,
Yeah.
everything gets 20x plus C. What is the understanding about B? B is the coefficient of x, it is a number in front of x. So C has no x on it. C is just a number that we do not know. Yeah. So the coefficient of x should be 20 because that is a number in front of x. So cannot be 20 plus C. Okay. Okay. Questions? So that's the answer for part A or part I. Okay. Let's really finish this up. Part 2. If C equals to 20, express y in your completed square form. And then hence find the coordinates of the maximum point. Okay, so the question specified that C is equal to 20. So we replace the C by 20. Then we do our completing the square, which you should be skillful by now. Because tomorrow is your Emacs LPA. What? I'm surprised that is news. X squared plus 4x plus 4 over 2 squared minus 4 over 2 squared plus 4. X plus 2 squared minus 6. Not enough? 5. Oh, from this angle I never see. Okay. Thank you. Yes. Minus. No wonder it doesn't get something. Minus 8 plus minus. Then minus. Then minus 8. Yes. Okay. So after getting the completed square form, to find the coordinates of the maximum point, question just wants you to find, wants you to state it. Okay. So maximum point will just be, what is that? The coordinates. What's the coordinates? 2 and 40, yeah? Okay? So don't need to go and do that working. Question just wants you to determine the coordinates. They didn't ask you to explain. Right? So, now, say something. Okay. So maximum value is 40. Then when this thing is equal to 0, then that will be. Okay? 40, right? Because when this thing is equals to 0, your square is equals to 0. So when your square is equals to 0, x minus 2 is equals to 0. That means x is equals to 1. Maximum happens at 40, right? Your maximum value of y. And when does that happen? It happens when the square part only have to have a negative 5. Okay, this thing equals to 0. So x minus 2 square equals to 0 means x minus 2 must equals to 0, right? Bring over, so x equals to 2. Okay, I will not go through part 3 because I don't find it meaningful to go through that. Okay, so we'll end here, okay, for our chapter 2.2. Right? Tomorrow our WA is just 30 minutes. After the WA, I want to continue teaching in maths. Okay? But I will give you a little bit of break, okay, to relieve yourself from whatever challenges you find in your maths WA first. Okay? So tomorrow please make sure you still bring your A maths materials. Okay? Our homework for exercise 2.2. It's over just now. Tomorrow got Okay, each question still after